Morning, everyone. Today is day 22 of Math 133. Happy Veterans Day, and I guess we are going to cover the Chapter 9 review worksheet. You'll find that on page 495 in your course pack, page 495. Um, so our final exam is on December 11th. Make sure you have that time set aside. You can also take that during the week, Tuesday through Friday. Um, if you have any questions about your grade, or if you have questions about, what are my chances, like what do I need to get on the final, like what are my chances of passing, let me know. We can talk through that, okay? Um, but for today, the Chapter 9 review worksheet. So I'm pretty sure we don't have anything in StatCrunch that we need for that. So uh, we are going to need StatCrunch, but not, there's no like data set that we need to pull in. So page 495. Okay. In 2020 CDC report, it was found that 52% of Michigan residents were over 60 had been vaccinated for shingles, with 1.9% margin of error and a 71% confidence level. That's a terrible confidence level. That's so low. Um, so uh, our sample here was, well, we don't have a sample, but what was the population? What was the population for this particular experiment? So sample is always like part of the population, right? Population though is all what? Yep. All Michigan residents over 60. You got it. Thank you, Andrew. Okay. Compute the confidence interval. So our confidence interval is so right here is our p hat. Okay. And in this case, it is 52.6%. Okay. If you go up by the margin of error, that'll put you at the upper limit. And if you go down by that margin of error, that'll put you at the lower limit. Okay. So in this case, all we would need to do is add the margin of error or subtract the margin of error. Now, in this particular case, we know the margin of error, but most of the time we have to compute it. Most of the time it's some kind of crazy formula with z alpha over 2 and a giant square root, and there's p hats and q hats, and it's a formula that we would find on page 259. Okay. But for this case, you don't need that because we just have the margin of error. It's already been computed for us. Okay. So your margin of error, if we add 1.9 to this, we would get our upper limit, which would be 54.5. Okay. If we were to subtract 1.9, because that's our margin of error, 52.6 minus 1.9 would be 50.7%. Okay. So we don't actually know uh, what percent of Michigan residents over 60 uh, have been vaccinated for shingles. Okay. Why why don't we know that? Well, because you can't measure the entire population. Okay. So you did a sample and You estimated that, oh, 52.6%, that's our p hat. We are 71% confident, which is a terrible confidence, but we're 71% confident that the true value is somewhere in this range. Okay. Now, there's still a 29% chance that it's lower than this or higher than this. Okay. Normally, we like to be more confident, but having a higher confidence level. So if I had increased my confidence level and said, I want to be 95% sure or 99% sure, you're going to end up with a very wide confidence interval. And so maybe they didn't have the money to do the study with a giant sample size. Um, and so they had to say, okay, well, we're going to use a small sample size and we're not going to be particularly accurate, but we'll have a nice small confidence interval, right? This confidence interval goes from 50 to 54. Okay. If I'd used a 99% confidence interval, this would have been like 30 to 70. It's like, okay, that's not helpful. Okay. That's too wide. Compute alpha. So your confidence level, one, if you add your confidence level plus your alpha, you get 100%. You get one. So if the confidence level is 71%, then what is alpha? If you add your confidence level plus your alpha, you get 100%. So what's my alpha in this case? 71 plus something gives me 100. 29. Thank you, Grace. Thank you, Kayla. 29%. Hmm. So that means when I shade this in, okay, 71% of this will get shaded, and the other 29% is the white space. Okay. Now that white space is split in two, so that alpha is actually split in two. So half of it's over here, half of it's over here. So like 14% over here, 14% over here. Okay. So when we calculate our Z values, which are these right here, it's actually Z alpha over two because, like I said, you split that alpha in half. Okay. So to calculate this, we need StatCrunch. So if you go to statcrunch.com, just type in statcrunch.com, and then sign in. This button right here should turn orange. Okay. When you first go to statcrunch.com, it'll be gray, and then you sign in, and it'll turn orange, and then you click on that, and it just opens a blank StatCrunch for you. Okay. Eventually, we'll open one. So to get the normal curve, we go to Stat, Calculators, Normal. Stat, Calculators, Normal. Okay. Confidence intervals, we're always going to be using between, and we need 71% of our data to fall in the red area here. So that's why I put in 0.71. And so I get my Z values, my critical values in this case are positive 1 and negative 1.0581. Okay. And I want to use this one as opposed to what we're going to do later, where we're going to look at proportion stats, one sample with summary. Okay. we'll look at this later, but I don't have a number of successes or a number of observations. They didn't give me the sample size, okay? So I'm not going to be able to use this one yet. That's why I'm using this one, stat calculators normal, okay? So I get, you can write out both if you want. I'm just going to be lazy and write plus or minus. Mathematicians are always lazy. That's why some of our abbreviations like this, Z alpha over 2, are just complicated because I'm too lazy to write like the critical values are blah, 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 blah. I just write it with symbols. And sometimes that's confusing, so apologize for that. All right, number 2. A researcher wants to construct a 93% confidence interval. That's better. It's more confidence. For the proportion of American women that say willpower alone is not enough for most people to lose weight. Estimate how many American women need to be surveyed if no prior estimate of P is available, and the researcher wants to be within 2.1% of the true population or true population proportion. We need the formula, we need the substitution, and we get the result. Okay. All right. So this you'll find on page 261. There's a couple formulas for calculating the sample size you need. Okay. So sample size for a mean, we're not using that one here. We're using a sample size for a population proportion. Now, it depends on whether you have a prior estimate or no prior estimate. Okay. They're asking us to do it with no prior estimate. So we're going to do this guy 0.25 CF over 2 divided by the error rate. That is our formula. N equals 0.25 Z alpha over 2 divided by the error rate. And then you square that. Okay. For your substitution, we plug in the numbers we have. So the error rate, they want to be within 0.25, or sorry, 0.21%. Okay. The Z alpha over 2, we're going to have to do in StatCrunch. So again, we want a 93% confidence interval. So what critical values go with that? So stat calculators, normal, I already have it up here. Make sure you click on between, put in your confidence level right here, hit compute. And so my Z alpha over 2 is 1.8119. Okay. Results. Gonna need the calculator for this one. Not doing that one in my head. On test day, nobody's ever gonna look at your calculator and be like, "Wait, you can't do 7 times 8 on test day." Use the calculator as much as you want. Okay, you have access to it. You have access to Desmos. Uh, you know, get familiar with it and use it. Right? No one's gonna be looking over your shoulder and saying like, "You should be able to do that in your head." Okay. All right. So 0.25, 1.8119 divided by 0.021. Use that, shift 6, square it. All right, and I get 1,861.10. Okay, so if you type this guy in your calculator, you get 1,861.10. So what is my final answer? Oh wait, I did something wrong, didn't I? Did I? Nope, that looks right.
The number's down right, but
Yep. The answer's just not matching the answer key.
yeah,
That's okay. I'm good with it. I'm good with that. I'm gonna make a note in my answer key here.
yeah.
Should be eight, two. Okay. Okay, so what do I put for my final answer? So if I was to round this, I would get 1,861, but that is not the correct answer. It is 1,862. Okay. So when you're doing sample sizes, we always round up. Okay. When you're doing percentiles, which was back in like chapter 5, we always round down. Okay. But for sample sizes, we're always going to round up. And the reason why is because if you were to round this down, you would be not getting a 93% confidence interval within 2.1% of the true population proportion. By rounding it down, you're making it a little less confident, or you're making it a little more prone to error. Okay. By rounding it up, we are actually improving our confidence level. So you might actually be looking at like a 94%, or you might be within like 2.0 of the true proportion. So anyway, 1,862. So that's a lot of people. Okay. So that might be, too many to ask. Like, I don't know. Do you even know 1,800 people? That's a lot of people to sample. So if we have a prior estimate, you'll be able to ask fewer people and still be getting a good confidence interval. Okay. But you don't always have a prior estimate. Um, Sometimes, like if I was asked this question, I have no idea. Okay. So having a prior estimate means like you ran the experiment once already. Okay. So if you have a prior estimate, you can use that in this formula, also on page 261, where you use p hat and q hat, same z alpha over 2, same margin of error. Okay. So research poll in 2024 estimates this proportion to be 0.71. So that is my p hat. Okay. My q hat then is 0.29. Not sure why we use 71% and then for both question 1 and 2. Interesting. Same margin of error and C alpha over 2 squared. Okay. But I'm going to get a different result because instead of using 0.25 out front, I'm using 0.71 and 0.29. Okay. So let's go back over here. Change this to 1 times 0.2. Okay. And now I get a little bit smaller sample size. 32.8, which I'm going to round up. I would have rounded that one up anyway, but I'm always going to round up when I'm talking about sample sizes. So 3 with it. Okay. So Doesn't look like much, but that's 300 less people that we have to ask, right? When you're doing a sample, you have to go and ask these people, and you have to, may have to pay for that experiment, or it might take time. Okay. So having a prior estimate is good because your sample size won't need to be quite as big. Now, I'll point out that, so here I have this formula, right? P times Q, P hat times Q hat. And in this one with no prior estimate, I have 0.25. Where does this 0.25 come from? What, like, why is that there? So if P hat was 50% and Q hat was 50%, what is zero point 0.5 times 0.5? 0.5 times 0.5 is 0.25. That's where the 0.25 is coming from. Okay. So if you had no prior estimate, you're like, what is the p-value? I have no idea. Just make a guess. Let's just say 50%. It's right in the middle. Okay. And that's where this no prior estimate is coming from. It's not actually doing it with no prior estimate. It is using a p hat and a q hat. It's just using p hat and q hat of 50%, 0.5. Okay. Because, a p value can be anywhere between 0 and 100%. So if you don't know what P is, just pick something in the middle, 50%, right? And that actually is going to cause you to have the largest possible sample size by using an estimate of 50%. So if you had no prior estimate or your prior estimate was 50%, it's not actually going to save you anything. Okay. In this case, our prior estimate is a little bit farther away from 50%, so we're going to have a little bit smaller. If we'd been even farther away, like if our prior estimate had been like 80% or 85, this would have been even smaller, okay? Or our sample size, that is. Okay. All right, sounds good. Moving on. Let's see. I'm going to skip past that. Um, my Q hat. So verify the requirements for constructing a confidence interval for P. So there's three that you have to check. Check that it's random, independent, and normal. Okay. If all of those are yes, then that means we can build a confidence interval. And the formula for that is on page 259. It's this guy. Okay. And your result for a confidence interval is always going to be two numbers. It's going to be a lower limit, comma, an upper limit. Okay. When you do this calculation, you can either do the calculation in Desmos once you have your substitution, or you can do it in StatCrunch. To do it in StatCrunch, you would do stat, proportion stats, one sample with summary. Okay. Interpret the interval. Whenever we say the word interpret, that means we want to write a sentence in English. Okay. All right. Next page is page 497. Um, So this is another one where they give you the margin of error instead of calculating it, right? The formula here for a confidence interval, the point estimate is the p hat. This whole thing here is the margin of error. The margin of error is z alpha over 2 times square root of p hat q hat, and it's this big thing. If you have to calculate the margin of error and then you add it or subtract it, then you can just do that in StackRange, okay? But if they give you the margin of error, then you have to just add that or subtract that from the point estimate, okay? Now, in this particular case, zoologist wants to measure the average weight of a male giraffe. That's what they're trying to get at. Is weight a proportion or a mean? That's a question for you guys. She knows from a San Diego Zoo study the male giraffe overall have a standard deviation of 541 pounds. So are we calculating a mean or a proportion here? This is a mean, yep. And you can see that in the actual question here, okay? So it's not this formula that we're going to be using. We're going to be using this one down here, okay? Page 259, the bottom formula, okay? Oh wait, oh, I'm wrong. This is the formula for calculating the confidence interval. We're not actually calculating confidence interval for this one. She's asking how many giraffes do you need to sample in order to estimate it? Okay, so that is on page 261 in the middle. Sample size to estimate a population mean. So that's this guy. Okay. Sorry about that. So as you can see, it's confusing to know like which formula am I using again? I've got this formula, I got this formula, I got this formula. I got all these millions of formulas, right? So um, it might be helpful if you write, yourself a little note in the margin or on your 8.5 by 11 piece of paper, like in your own words, when would you be using this? Page 259, this page is for actually constructing the confidence interval, okay? Actually creating it. But you can't create the confidence interval until you've taken a sample and measured that, right? So in her case, she hasn't actually done any measuring yet. She has a prior estimate. She has a margin. She wants this margin of error. She wants this confidence interval, right? But she hasn't actually taken her sample yet. How many giraffes does she need to study to estimate the population mean? Okay. So when you don't have a sample that you've estimated yet, that's what the stuff on page 261 is for. Okay. So in practice, the first thing that we would do, okay, is we would calculate our sample size. Actually, that's not even true. The first thing we would do is we would talk about what confidence interval we want and what margin of error, okay? This confidence interval and the margin of error are not just numbers that you can just pick out of a hat. These are important to discuss with whoever you're talking about, whether it's your boss or your, business leaders or whoever. Like, I'm going to, do this study and we're going to spend time on it and money on it. We want to make sure it's useful. So, how confident does this study need to be? And if they say to you, well, it's got to be 100% accurate. Well, we've already said it can't be 100% accurate because you can't measure the whole population. But what confidence level can you still make an informed business decision around? Why does she need to know this? Why does she need to know the average weight of male giraffes? Well, maybe she is, you know, trying to figure out like how much medicine or how much food they need to purchase um, for, next year. And that's going to be based on like how big the giraffes are, how much do they eat, right? So do I need it to be 100% accurate? No. If it's 90% accurate, like I order a little bit too much food or a little too less food, we can deal with that. Okay? We can fix that. Okay? So these are the first things that you would talk about with the business or your leader or whoever is how confident do we need to be? How big of a margin of error is acceptable? Okay. Then we would use our formulas and figure out, okay, how big of a sample size do I need? And I go out. The next step would be to go out and actually take a random sample, make sure it's random, which is difficult, but take a random sample and then measure those things. And I don't know how hard it is to measure the weight of a giraffe, but but if I had to do that 1,000 times, like that's still difficult to do. So, um, the last step after you've done all of that and collected your sample and gotten your data is to actually build the confidence interval. Okay. So the confidence interval is, even though for this chapter we're building confidence intervals all the time. It's actually the easiest part of the whole thing because I just plug the numbers into my formula here and I'm good. Okay. So, all right. Anyway, moving on. So sample size from part A would be larger or smaller if our confidence level was raised. Sample size would be larger, or smaller if the margin of error was raised, and so on. Okay. All of this you'll find on pages 207 and 208. Okay. The main thing is that a larger sample size means you'll be more accurate. Okay. So I usually don't even look at page 207 and 208. As long as I have that in mind, I'm going to be fine. Okay. A larger sample size means you'll be more confident. It means you'll have a smaller margin of error, right? Smaller error is good. Smaller error means you're more accurate. Okay. Um, but if you struggle with these kind of questions, take a look at page 207, 208. Okay. Okay. So we'll skip past this. Now, yeah, I'll come back to that later. Next page is page 498. Researcher gathered the in-state tuition for a random sample of 15 four-year colleges. Verify the conditions are met. So, okay. So we're constructing a confidence interval for a mean. Okay. So construct the confidence interval. So there's a formula for that. All right. This one is the one that's on page 259 at the bottom. Because now we're actually constructing the confidence interval. So there's the formula. Do your substitution. Get your result. Okay. Now, one thing you'll notice about the difference between the formula at the top and the formula at the bottom is this one is Z alpha over 2, and this one is T alpha over 2. So T alpha is not using the normal curve. It's using a student T curve, and the T curve looks very similar to the normal curve. And you can treat it very much the same, except that there's one small difference, which is you have to know what the degrees of freedom are. The degrees of freedom are one less than your sample size. Okay. Um, so what the heck does that mean? Well, it means that uh, the bigger your sample, the more accurate, which we've already discussed. Okay. But it also means that uh, we might ask about this where we give you the n value and ask for the degrees of freedom, or we might ask for the opposite, where you have the degrees of freedom and have to find the sample size. Okay. Anyway, so interpret the confidence interval. That just means write a sentence. Okay. So there's that. This particular worksheet actually does have 5 pages, so page 599, and then we'll jump back in. Researcher for the Bureau of Labor Statistics created confidence intervals for the amount of the U.S. households spend on transportation. So they've already done the confidence interval for us, okay? So really this is just reading off the StatCrunch. So confidence level here is one of these numbers. Alpha is, well, remember that the confidence, so if you add your confidence level plus your alpha, you get 100%, okay? Yeah. So I'm going to skip most of that. So in general, the interval would be narrower or wider or the same, depending on if you lower your sample size. So again, you can check on page 207 and 208, talk about whether it's narrower or wider. I think that is all the hints I'm going to give you today. So let's go back to page 495 and I'll stop the recording.